Alright, for this week's sprint, like I mentioned in class, ripped out the entirety of the old terrain test class and started it anew. I wasn't happy with how things were going, and so I made it better. So here we have, this is the terrain object. This is after it's hooked into the rest of the systems. We've got our terrain cell here. We've got an iterator here for providing access for collision. Um, this feels kind of like it's cheating because I'm just, utilizing the same iterator that the list has already. But it works and doesn't really need any of the it doesn't give the outside classes any access to the actual collection. So I think that's what we're trying to do. So let's just hop right into it here. So the constructor goes in and constructs a name that'll be useful later for loading into the model manager. The create terrain model here finishes out the name, and then checks to see if it already exists. So the name is file path underscore repeat u underscore repeat v. So that means if the same file and the same repeat u and v are used, we already have the model loaded in, so we don't need to do all the creation and stuff down there. Unfortunately, at the moment, we still need the to read in the height map for every terrain object that's being created, regardless of whether or not we've already created a model, because it's the only way to get these numbers calculated is we need the image width from the file. Um, I'm sure there's some way to avoid this, either by passing in an argument or otherwise saving this data somehow, but I haven't got around to fixing that. It's um, on the free time to-do list. So as for the actual creation, we've got the XYZ, the UV creation. Then we've got down here the triangles. Obviously, as I mentioned on Perforce, I had to do it clockwise instead of counterclockwise. Not entirely sure why, but it works. And then setting up the cells also. And then obviously saving out the model, loading it back in using that name that we calculated earlier. If the model already exists, the only thing we need to do is set up the cells, so that's that right there. There's also various accessor functions, translations to, make life simpler for me. So with that out of the way, and that, was reliably confirmed in my test earlier, rigorously investigated. That done, I moved on to creating a terrain load manager so that the user could load these in um, the load assets. Is that what it's called? Load resources. Yeah. So that's wrong. It automatically starts at height maps. So the user, I'll just show it from the user side. That'll be easier. So the user wants to load in a terrain. They pass in the key, the height map, the final scale in world, the max height in world. This is the 0 height is currently unused. I'm not exactly sure how to integrate that in, and it's on the luxury to-do list. This is the ID of the already loaded in texture. So something like this here, plain grid, and the UV repeats U and V. That gets loaded in and sent into the constructor here, and then It's available for use later by, for example, the scene. So if this on the scene side, the user can say set terrain, pass in only the key, and the scene will set the current terrain via the terrain manager here. Will set the current terrain to whatever is passed in, obviously loaded in through the asset manager, the get terrain here. The current terrain manager, the only thing it's in charge of is making sure that any other registers, collision, that need a terrain set before they can actually work. It's in charge of checking to see whether that has actually happened, and then rendering the terrain every frame. And that's done through the scenes update call here in the draw terrain. For collision, so let's go ahead and show this from the user side also. Objects. So the terrain is set. We want to register the frigate textured for collision with the terrain. That stuff goes through the proper managers. Register collision. So this is something that was a little different than our other register collisions. For the terrain, we have to actually pass in the let's see. Right. So we have to actually register in the current terrain to uh, the test command because it needs access to the terrain's iterator functions. We can't just use uh, singleton the singleton objects that we already have like we do for the other um, collision functions. So that means that if I, like I do in my terrain demo scene, want to both set and register collision at the same time, the register collision terrain, if we had done it the way we do for the other um, collision registers, that is, without a command system, just done instantaneously, that would be done before the set terrain actually processes at the top of the next frame. So you'd be registering to collide with a null object, which is obviously not what we want to do. So the scene here sends it through the command system. Make sure that a terrain is set before it actually registers with the collision manager, which creates this right here, the collision test command that's processed through like all our other collision test commands. It has its tiered system here that checks for every cell if the ABB collides, if the B sphere collides, um, and then if the actual volume collides. Um, then there's, of course, the callback here. Go to the callback in the game object collidable class that is called back when when an object registered for collision actually does hit that object. In the case of the demo here, the boop 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 will say frigate collide with terrain. If I go ahead and run this now, you will see that all of these things. Oh, I need to check out my things. Ha ha ha. All of these things do happen as stated. So there we have the frigate colliding with the terrain. It zooms its way over the terrain. Yellow means colliding with ABB, orange with the B sphere, and red with the actual volume itself. So there you have it. I didn't get to get the exact position on the terrain projection done, and I didn't get the normal calculations implemented yet. That's on the to-do list later on the stack. Switching gears now to the individual project. I added a little bit onto my document here, basically just saying that the stuff I describe for like the types of goals that need to actually be created, those are actually just about the only thing that's going to be needed um, as far as structure goes. I'm going to create another ubl that automatically creates a base node, and then the user will just add new nodes on top of that that are connected, though now that I'm thinking about it, it's a little more complicated than I put together structurally. Um, because of the need to make sure everything is slotted in the right place. Though I guess with the if I want to add a new goal, it will just append to the base goal and sub goals of that, you know, secondary, like the one that I'm appending has its own sub goals, but I don't need to add those in explicitly add those to the system graph. Anyway, what it boils down to is the prototype that I have from the game AI class. Basically, a goal just gets processed through the update tick gets sent through, and it processes sub goals as as defined, as I've talked about a little bit in this paper over here. Didn't get a chance to do a lot of actual work in the QuartzEngine on that this week because, like I said, I was ripping out the whole terrain and redoing it to actually work. But now with that out of the way, it's going to be working on that basically for the rest of the quarter if I don't misinterpret things. But that's all for this week.